Okay, so today we're going to talk about exponential regression. Exponential regression has this form right here. Y is equal to a times b to the x power. Now we have two different types. We have growth and we have decay. So growth, we're going from left to right, we're going up, we have an increase. Decay, from left to right, we have a decrease. So example 1 says, let's create a scatter plot that models a model of exponential growth would be a good regression model for it. So here's just an example. Starts going up pretty quickly. And then decay, we have a quick drop, and then it eventually flattens out. Okay, so that's example 1. Now, the way I put these in the calculator is just like we've been doing all the other regression models. There's actually a command for it. So, looking at this one, it says, the table below gives the population of the world in billions for selected years during the 1900s. So we've got these years up top, but this is what we're going to put in our X, our L1, because this is years since 1900. So let's put years since 1900 in our L1 and population in our L2. Okay, once you get them in L1 and L2, we're going to do like we did before. We're going to set our window. So go to window. Our smallest x value is 0, so we need to set our x min, so something smaller than 0. So I did -1. We need to set our x max to something bigger than 100, so you can just do 101. Now our y min, our smallest y value is 1.65, so set our y min to 1. And our y max, our biggest y, is 6.06, so let's set our y max to 7. Now press graph. Now if you take a look at it, we can look back at the previous slide and decide, do we have an exponential growth or decay model? We actually have a growth model because we're going up from left to right. So when you press stat, you go over to calc this time, and you go to, it's 0 EXP REG, exponential regression. It says press enter, and then press enter until your model pops up on your screen. So we have exponential growth, and our model is y is equal to 1.4457 times 1.0137 to the x power. So now it says use the equation to predict the population in the world in 2050. So, but the x values we've been using are numbers from 0 to 100 because we're trying to do years past 1900. So to figure out how many years have elapsed, we take 2050 and we subtract 1900. And we get 150. So that's what we're plugging in for our x value. So we have 1.4457 times 1.0137 to the power of 150. And type it in your calculator exactly like that. And we get 11.13, and I'm going to do 2 decimal places because that's what's in our chart, billion people. Let's move on to example 3. Okay, in example 3 it says the data below gives the number of bacteria in millions found in a certain culture. So we have our time listed above the top and our bacteria numbers listed across the bottom. So it says find an exponential function that models the bacteria data shown. So go to stat, put your time in L1, your bacteria in L2. Then take a look at your window and decide if we have growth or decay. Once you do this, you'll find that we have exponential growth. So do our model. Stat, over to calc, go down to 0 EXP reg, and our model is y is equal to 4.7818 times 1.7687 to the x power. So that's our model. Now let's take a look at B. B says, use the model to estimate the time needed to double the initial amount of bacteria in the culture. So the initial amount of bacteria in the culture is 5, so to double it, we will need 10 bacteria. So this is actually a y value. This is a little bit different than the previous example. So we're going to take our equation, but we're going to plug in 10 for y. So we have 10 is equal to 4.7818 times 1.7687 to the x power. Now we've got to pull back from a couple units ago. We've got to solve this, and we're going to use some logarithms to do so. So before we start doing our logs, we need to get this right here isolated. So we need to divide both sides by 4.7818. Okay, so then you end up with, on the left-hand side, 2.0913, and that's equal to 1.7687 to the x power. And I'm actually running out of room, so I'm going to go to the next slide with this. Okay, now here's where we got to use stuff from our previous units. If we have an x for the exponent, we can use logs. So we take the log of both sides, get 2.0913, log of 1.7687, and this is to the x power. Then we can use that power property that says that we can take this x and we can put it to the front. So I haven't changed the left-hand side. And now I'm going to have x times log of 1.7687. Now the last thing we have to do to get x by itself is divide both sides by log of 1.7687. These cancel out. So in your calculator, you need to put this in there. Make sure you use parentheses to close your logarithms, or else you won't end up with the right answer. And you get 1.29, and this is our x value, and our x is measured in hours. So we have 1.29 hours is how long it takes for our bacteria population to double.